So, welcome all the participants, those who are uh, participating in this 2 week HTTP on the cryptocurrencies, blockchain, and recent trends in technology. I am Dr. Vinayak Paradi, Head of Department Information Technology, and today's speaker. So, please, I request all of you, those who are participating, please put your name and affiliation in the comment section. Okay. So I will start in a couple of minutes. Today's topic for discussion is using long short term. Yeah, we'll start. I hope I'm audible to all of you. Yeah. So yeah, so this is if possible, if time permits, we'll have some small demo. So understanding AI ML DL and how this is relevant to this blockchain and cryptocurrency or this overall things are that yeah, it is one of the recent trend. Beyond that, in case of some of the smart contract or kind of specific applications, you may have what you can say to need expertise which requires the machine learning, deep learning, and AI. So overall, this is one of the coming trend, recent trend, and we are covering one specific part of this overall big term, that is the sequential networks. And in this sequential network, recurrent network, which are specifically aimed at what you can say the data which is coming in sequence. So let us see what is that. So we start with neural network. So this neural network can approximate or learn to repeat any function. This is the basic what you can say the thing that we should understand. They can model anything. So maybe those who remember the basics of these neural networks are taught. We start with linear and non-linear, and then this what you can say single layer or network they fail to classify what you can say linear non-linear function like XOR, and then we go on adding the multiple layers, and these multiple layers when we add to the network, this network can approximate any specific curve after specific, and rather than curve I'll say function after a desired level of training. Okay, so yes, machine learning is the thing, the domain that we are actually studying. The definition is there in front of you. So we want the machine to mimic the what you can say the functionality of human brain. Human brain has got massive interconnected networks of neurons, and these neurons are connected inside our brain, which their synapses, and they communicate with the electrochemical process. So chemical what you can say compounds are used to pass message, and this is very fast. The billions and billions of neurons working on a specific thought process, and because of this parallel what you can say operation and massive interconnections, a human brain can recognize, can store, can work on various things. So we want the same to be done by the machine. And here the concept of machine learning comes, where we build artificial neural network. In our brain, we are having neural networks. Here we build artificial neural network, and depending on the problem, whether it's classification of single dimensional data, multi-dimensional data, the data which is coming in sequence such as the audio, video, or simple text string, various types of networks have been put forward. And overall, the artificial intelligence and machine learning, this connection, I will just briefly here you can see this AI is overall a big domain, and beside this AI, we are having this machine learning and deep learning. Machine learning is just I discussed that. Uh, where we want to. AI is overall mimicking human brain. Machine learning, we are writing what you can say specific code. We are designing specific neural network which will follow the functionality of human brain. And when these networks are having multiple layers, deep layers, and they need what you can say a specific kind of input data which is designated for the architecture, then as the number of layer goes, what you can say more, the complexity of network grows, it comes into the deep learning part. So yes, this deep learning, here you can see the growth of deep learning over all over world, and it is shown in terms of the technical publications which are uh, targeted in this deep learning domain. So here you can see. So here you can see from 1950, so almost 1990. Things are these publications are almost what you can say uh, at specific range or a specific section is there. But from 1990 onwards, there is an exponential growth in this time. And here from 2010 onwards, this is further exponentially growing. It is almost now these people who are studying this thing, it is almost exploded. So there are many factors, and they are actually classifying this as for deep learning one, deep learning two, maybe deep learning three and four. Actually, human this the intelligence of machines and intelligence of humans. Maybe in coming time they will be matching. Currently, we are at the level of ape and chimpanzees, but beyond that, the scientists are working so that machine can match human intelligence. And one big thing that has fueled this growth is the availability of hardware and platforms which are used to write the programs with the development of languages such as Python, then various frameworks such as Keras, PyTorch, machine learning, natural language toolkit, a number of things are there. So more and more, and these are many of these frameworks are open source. So because of that thing, these applications have got researcher interest, and overall this is becoming a buzzword. So here you can see 1980s era neural network, because during this time the technological capacity of this, what you can say, uh, network were quite limited because of the compute power which was available at time. And here, deep learning network, here you can see that multiple layers are there. There is layer one, hidden layer two, hidden layer three, and maybe the complex network may have more number of hidden layers. So this network can carry more complex paths. Like every layer, maybe you can target for identifying edges, combination of edges, admin feature, and overall, then final this layer, output layer, dense layer can be used for classification, for multi-layer classification. So where it can recognize a person. So this is a depiction between a very pretty categorically very basic difference between how what you can say one typical normal single layer network and multiple layer network. Yeah, so here I just mentioned this computing resources, algorithms, and others they have fueled the task. Okay. So rather than going with, yeah, we'll come for this RNN and LSTMs. So specific type of what you can say data uh, we are considering today. So when you have this multi-layer perceptron, so they take data in terms of patterns, number patterns. When one pattern is given, and it classifies that pattern in class one, class two, class three, class four, class n, and then next pattern, next pattern, next pattern. The training set is there, label training data is there, and we go on. But where the data doesn't always come. So here you can see this pattern is marked here. Here you can see the pattern is marked here, where here you can see figure 8 is there, and we are trying to recognize this pattern 8. So here typically what will happen, that this is 1 2 3 4 5 6 blocks by suppose 8 blocks are there. So 6 blocks by 8 block, what you can say, one 648, what you can say, uh, points will be there, pixels will be there, and this 14 pixel pattern will be given to the neural network. And once neural network will take this thing, it will process that, learn that, and then classify that picture. But here, suppose now we are having data which is actually coming over a period of time. and many of natural events occur like that. And for example, the daily temperature, that weather reports are there, daily temperature is there. So based on that, if I have the last 4 months data, can you predict tomorrow? So yes, it is having pattern, it is having data, it is having what you can say, uh, one what you can say graph kind of appearance. But this typical MLP, they won't be able to classify or work on such data because they are not designed for that. So for such kind of data, here you can say another graph can be seen on the screen. So here you can see this from 2008 to year 2020. Here this network is graph is mentioned here, and this is stock market prediction. And here this is one of the after 2020. Now we want to predict whether this market will go up here or go down. So to process this thing, this conventional network won't work, and there we need recurrent networks. So here, so recurrent network are specifically designed for current data, past data, and future data. Okay, it will always predict future based on current and past data. Okay, so here you can see how this actually this is another concept or long concept, but here you can see that yeah, xt is your current input, and then this is your network, your cell, typical your cell rnn cell is there, and it is predicting what you can say the next what output. And when it is considering next what you can say level, it will take current hidden state for the prediction purpose, and it will go on. It will go on hidden state plus output. So like this thing, x0, x1, x2, x, these are the time steps. It will take input. Okay, to predict for initial block there is no past one, but here this is hidden state. It will go to next state. For next time step, it will take next time input, past input, and predict the future. Like this thing. So data will come on sequentially x1, x2, today's temperature, tomorrow's temperature, day after tomorrow's temperature. Based on that, it can predict what based on the past, it will predict the future. Past and current input, it will predict the future. So these are the typical functionalities of one neural network. And the networks are trained through concept called as BPTT, back propagation through time. So again, here today's discussion, I will limit to the limitations of RNN because this is kind of so you should know basics of RNN basics, and then why we are going for what you can say modification in this thing. So here I just mentioned the concept this back propagation through time, because now this network what always the data is coming in a sequence. S1, S2 sequence means this input 1, input 2, input 3, input 4, and this x always it will be taken at xt. And what will happen, we'll always have this based on this xt, we have to predict xt plus 1, x on xt plus 1 and xt plus 2, like this thing it will go on. So whatever the weights and this output it is going to be generating, it has to back propagate through the past time steps. And the hidden state, whenever the network updates its weights, like you should understand how the back propagation, normal back propagation work. It will work for the current pattern, but here in case of this recurrent network, it will work for the current and past states. So typically when the learn weights are whatever the delta and intermediate calculation values are passed for the network training, they are passed through the time steps for the back past data, past instances, and hence the name is called as, and this process is called as referred as back propagation through time. Okay, so lots of literatures are available for that. What I want to specifically discuss is that the problem which comes because of this nature of this. Here you can see now. Here, here. So this is x0 to xn, this network as per, and these are all time steps. And when network is going to learn, it is going to propagate data like this through time. Idea is that when we want to predict some data x4 and we want to predict x5, then we should have the knowledge of all past input ideally, but that is not practically possible. So what happens that when network or these time steps go on increasing, the past knowledge becomes what you can say faded. It is no more impact what you can say impacting the current state. For example, suppose we want to predict the for example typical number of sales of a product. And typically, suppose people are having holidays, they predict. It is observed that on Friday and Saturday, typically people go for online shopping, for example. And then okay, then what happens? The network every days Sunday, Monday, Tuesday, Wednesday, like this thing. We give the typical today's sales count, and then on a typical day, you want to predict that what can be the sales count. But can so that we can have an itinerary. Fine. Then on Monday, Tuesday, depending on the past values, you may say that okay, maybe average typically, or the network will learn and say that okay, on this Monday it is average sales of like maybe 100 units, as compared to Saturday we are having 500 units. Now suppose it happens that Monday becomes the Diwali, for example, past 4 days, because on Friday there is Diwali and Monday is the day. So what will happen? People will try to buy gift for their loved ones on the Diwali day. Hence, on Monday, typically the Saturday volume is 400 units, but Monday volume is 1000 units. So how will come to know? Because it has happened 1 year back, or maybe or if you say for a specific example that maybe the 14th February is there, Valentine's Day. Every Valentine's Day, people have this before 2 or 3 days. It is having the huge shopping volumes. Or typical events are there. 15th August, there is a what you can say specific sale is there. 26th January sale is there. New Year sale is there. So these events are key events. So while training, we should remember, the network should remember such events are there, and these events impact, these dates impact. Maybe the Diwali comes on Tithi, but maybe 15th August and other such key event get Thanksgiving Day, it just happened. Christmas, it is now coming. So these festival come on specific dates, and these dates are very key. So if I know that even 25th December, it has to be huge shopping. It has to be huge shopping. And network has to remember that, where in case of normal training algorithm, this won't happen. And it is called as actually exploding or vanishing gradients. This concept typically. The network doesn't remember the key event, and it fails to predict what key event. Here you can see the how typical data is going. Network is what I can say processing that thing, and then there is a typical RNN cell, past input, current input. It is processing and predicting. But as these details I'm not taking, yes, I want to take this vanishing gradient. What happens that as we move ahead and ahead, the key steps or key events fade into history. And if you want, so this I just gave example. So if you say that okay, we always remember that Thanksgiving Day is there, or maybe Independence Day is there, or maybe Diwali is there. On this day, shopping volume is high. So you have to take this as key events, and then when suppose the Diwali is there on maybe 4th, then you should have that okay, maybe by 4th we may have additional traffic on our web shopping site. So to make such thing happens, here normal whenever the normal network updates its weight, these events won't be remembered. So key events, or if some event has to make impact on its future prediction, it has to go through. And this modification is required in this RNN architecture, and this architecture is called as long short-term memory networks. So here I just mentioned this. What you can say, exploding gradients means what unnecessarily if you go on emphasizing the thing which is not important, it will go on having its value, and then current event may not be that much. What you can say, deciding the future. If you want to give more weight in the past, exploding gradient, and vanishing gradient means important event fading. Okay, so this exploding and vanishing gradients are problem with RNN, and we have to decide which event or which specific instance should be remembered and carried forward in order to make it impacts on the prediction. And if we are able to do this thing, this we will be solving the problem of exploding and vanishing gradient. Remaining events we will forget, and this is done through this I just mentioned vanishing gradient. through this is called as long term dependency problem. Okay, this is another example. I live in France and I know French. Okay, so I know that whenever France comes for the prediction purpose, French should come. But depending on the history of training, it may say that I live in France, but over the English language that I know English. But France has impact on French. That person should know that. Okay, so France is key term. It should be remembered and taking while predicting the next word. Okay, so that's why these LSTM come in picture, where they what you can say do this, because here is short-term memory. These normal RNNs, they are having short-term memory. So like maybe they will remember a couple of steps, but key phrases, key steps, key instance from the past they forget. So this problem, maybe this long-term dependencies are not remembered, or it is having short-term memory. So this is the name of same two names of same problem only. So to solve this thing here, this we have long short-term memory networks. So then the name is what? LSTM, long short-term memory network. So long short-term, and this network. So again, if you go to the literature, lots of things are available. But key term I want to explain or make you understand today. The key term. So why LSTMs? Okay, there is another gated recurrent units, but I won't be stressing on that. But why LSTMs are better? And now there are very, what you can say, various uh, derivatives of this RNNs, because LSTM is also RNN. So RNA, recurrent net neural networks, are the basic, and there are now various, what you can say, derivatives have come, or variants of these RNNs have come. Like latest ones are this sliding windows, swing transformers. Okay, then content adaptive recurrent content adaptive recurrent units are there. Uh, then code networks are there. CNN with attention, these networks are there. So lots of what you can say modifications and research is happening, and you will find many future direction. LSTM with attention, LSTM without attention. There are various types of LSTMs, hundreds of not hundred, but maybe at least 5 to 15 types are there, like bidirectional LSTM, time distributed LSTM. So this, you if you want to explore LSTM, you are welcome to go through history. But how LSTMs are changing the game plan, that we'll discuss. So this is a typical say. This is a key part of today's discussion. Once you understand this thing, what is happening here, then you understand the majority of LSTM work. So here, what happens that these typical RNNs, they have problem of long-term dependency. So we have to decide what I should carry forward and what I should forget. Okay, remember this thing, what I should carry forward and what I should forget. So that's why whenever you, if you can see, this is a typical LSTM cell. Here, memory cell, this is single cell, this is not this say such hundreds and thousands, depending on your, what you can say, network architecture, as well as how many input sequence points are there. You will have to go on adding or cascading the LSTM cells. But typically, one cell will have forget gate, input gate, and output gate. This is the important thing. So this is very important. Now, forget gate is there and output gate is there. So what happens that, and this is your, you can say, your input is there, your current output is there. Okay, then here cell state is there, and this past output is there. Okay, so here you can say cell state CT, HT is your output, XT is input, and from the past output you can, it is seen, and past cell state can be seen here. So always this LSTM will take three input, that is XT, your past, what you can say, output, and cell state, past cell state, and it will give you what, current output, and cell state will be generated current cell state and current output. This is the parallel thing, it will go for next. Now what is this change is going to get or bring the importance, that is very important. Okay, so this is sigmoid function here, sigmoid, tan hyperbolic sigmoid. Then this is XOR is here. Here, sorry, this is simple addition, here concatenation. This is your multiplication. Here you can see these things are converted, and here it is output is generated. This is simple. What you can say, uh, patching through. That is output going. Output is simply copied here as well as here also. Okay, these are the simple thing. Now, see, try to understand this. XT and pass states are given simultaneously through the forget gate, through the input gate, to the input gate, and to the output gate. Okay. Now, what is happening is that this forget gate will decide whether this current input is important or not through this sigmoid function. Okay, whether to remember current input along with the past input and cell state, past cell state. So this is as good as I'm trying to decide whether current instance is impactful or not. Means what? If impact of current what you can say state, should I carry forward to my future prediction, or should I drop it here only because I don't see it is important, and I should only take that, okay, what is the signal which I am going to propagate from the past. This is very important. Okay, so this is decided by the forget gate. Then input gate will take what your AXT, HT. Here you can see they are going as input here, and tiny hyperbolic function, sigmoid function is there. Besides that, it will also concatenate this intermediate, what you can say, your XT HT combination through this process along with the cell state, and this will generate current cell state. So at currently, whatever input and path combination I am having, this is my what you can say existence, current time instance existence. Along that, if any past existence through the forget gate I want to carry forward, I will add it here. If forget gate says that okay, past things are not that important, only current thing is important, the forget gate will allow that thing to happen here. So this forget gate will, it is something like that. If there is what you can say from past, if now I want to say that I live in French and I know I want to predict. So I live in French. So this French I want to preserve. This is going to be preserved through this tail state propagation, cell state propagation. And French will come, cell state will say that okay, yes, next time the moment I know will come, yes, French was there, and from that it will go and say that yes, the next prediction has to be I live in France, I know French. So I live in France is the impactful word that should be remembered, and that will be remembered through the forget gate. If it is forget gate will say no, don't forget this thing, carry forward for the future state, and this will be, this France will be coming as the city also here, and that will impact the moment I know comes French. Okay, because previously the person has said that I live in France. So when I say I know, then for the from the past French is related, France is related to French. This will be easier to predict. This will be easier to predict. Okay, and then beyond that, from this cell state, what you can, this is here another what you can say branch or section of this LSTM. Through this tan hyperbolic function and cell state, we are going to predict current output. This current output is going here. So this is very important. This screen, this what you can say, LSTM cell description is very important. Those who are attending this session online mode, or maybe they will attend in future, if you are able to under, there are many videos are available. So go through this thing. If you able, if you understand this concept, then you understand LSTM. Then you understand LSTM. Rest things are how to build LSTM, how to give input to LSTM, how to train the network, and that demo will have. So this is one part very important. Yeah, this I just explained this all these things. Forget get input, get cell state, output get. Okay. Yeah. So what we'll do today, I will show you one small demo. Yeah, I will show you one small demo I have with me. Yeah. So yes, I'm having today. So I will share the tab. Yes. So what I'm building today here, or demonstration here, you can see this typical LSTM, typical Google Colab screenshot screen is here. And uh, this is my old code, where what I did is that I took the sequential data of COVID cases, and this data is what is happening in every day. The COVID, I will just connect to my Google Drive. It is on my Google Drive. Here is this data. Here you can see from zero day, that is almost December 19 to almost 700 days. This 2 years data is there, and the way the COVID cases have gone increasing. This is simple data for case study purpose I have taken. And then here total there are almost 7 heads total confirmed cases globally, total confirmed death globally, total recovered people, total confirmed India, total confirmed cases in India, total deaths in India, total recovered people in India, total confirmed cases US, total death US, and total recovered US. So these are the seven what I can say sequences I am taking, and based on the past value I should be able to predict the future values. This is the task which is there in front of us. So for this thing, for this purpose, now this I am having almost 700, almost 675 something points are there. 673 points are there, and nine dimensions are there. Means 9 points are nine. This uh, heads are there. Okay, so there is always uh, 9 dimensions. So whenever you are giving data to a typical LSTM, you have to format that data. So how to format that data? This code is here. Those who are interested, I will give them. Okay. As of now, I'm going to just demo run it. So it is normalized 0 to 1 first of all. Then here you can see. So here you can see now all entries. You will see this data is normalized to 0 to 1. So this here you can see the maximum is zero, minimum is 0, maximum is 1, and data normalization is done for this time frame. And this is very important. This is the next step that we are doing is that from this single sequence data here, here. So okay, this is a one for current input, this zeroth vector. Its future is 1. Then one's future is two, two's future is three, three's future is four. This is the concept. So what we have to do, we have to generate a time shifted version of this as training data. Because if this is current, this is next. If zero is current data, future is one. If one is current data, future is two. Because like we label the data in normal network, when we train this sequential network, this recurrent network, we have to train based on the future data. So how you will get future data? Because you know the 0, 1, 2, 3. So that's why it is called as time shifted. So here there are nine what you can say vectors. So when we time shift that, it will have 18 vectors. Here you can see key part. Okay. So here if you see 672 into 18, because time shifted version of that we have generated. And now we'll use this data for prediction purpose. So this is your x, this is your y. 672 9, 672 9. So then training and testing data is separated. This is very basic level, X train, X test. Another thing that is very important now, that sequence, time step, and sequence, number of time step, okay, and dimensions order. Okay, so this always whenever you train this LSTM, you will make sure that the data is formatted in this. Many books or many online discussions, then they don't show this thing. They don't show this thing. So how many time steps you want to have in your data? If you have want to have simply one time step, means what? For a prediction, how many time step the LSTM should consider? One, two, three, four. Accordingly, you will have to generate this input sequence from the. So what happens that I am now saying that this my LSTM should consider four time step. Whenever I want to predict tomorrow's cases, I should see that today's day before today, day before today, yesterday, day before yesterday, and one more day. Like this thing, 4 days I will take in consideration while I'm predicting tomorrow's case. So this will give me better idea of the past so that I can predict the future better. So sequence, number of sample, time step, and how many features are there. Remember this thing: sample, time step, and feature. This is in Keras. So if you want to train LSTM, you will have to format your data in this thing. So this is a code which will we have to simply pass this code. Small code is there. It will generate that thing. So if you are interested, always you can uh, mail your query to me on vinayak.bharadi, vinayak.bharadi @fmd.ac.in, or you can visit my institute website fmd.ac.in. Go to IT department, and there my email ID is there. You can contact me from that. You can contact college and get my ID. So those whoever watches this thing in future, it will be helpful. But remember, because many online discussion, many videos, they won't, or they, I don't say, they might be explaining that yes, you know this thing. That's why when you say that, here you can see now how one single training instance looks like this here. Yeah, when you say, so here, one, two, three, four time steps, and such 533 entries are there, and each entity is having 9 dimensions, 9 features. So sequence, time step, and features. Remember this thing. And output is what? Simple, one entity and its features. So from this 4 past days data, I am going to predict what might be tomorrow's instance. So this is the thing. Okay, so let us now build and train. Here you can see XTYT, number of sample. Yes, here it is a simple network. This is basic LSTM network. I am building sequential network, and here this is input layer. This is hidden layer one, hidden layer two, output layer, that is dense. Okay, number of features is going to predict. Okay, the dense layer is there, and here you can see the input shape is number of time step and number of features. This is the standard one, number of time step, number of features, because samples they are going to be there through the training for the training purpose. So number of time step and number of feature which the LSTM will take. So 4 time step and features, and then you train this network for whatever the samples which are available with you, training samples which are available with you. Okay, and typically it will always ask you how many neurons you want to have. So here you can see the neurons where I have taken 700 neurons. They should be greater than typically the your sample size. So 700 neurons I have taken. You can experiment with less number of neurons, more number of neurons, but I am taking. This is the typical plot. Here you can see for your network input layer, hidden layer, hidden layer, hidden layer, output layer. So these calculations they show the feature I want to. Let us train the network. Yeah. It won't take much time. Network is training. So meantime, let the network get trained. I will show you my past training output. By the time our discussion is open, if it is training, fine. Otherwise, it will take another 15 to 20 minutes. Okay, let it be. So this is my past data. Here you can see the training loss is there. Network is almost what you can say train. Here now I will show you here the prediction part. Okay, here so prediction part is here. Yeah, this is the predicted data, but for that sequence I am showing. So when we put this thing on actual one, here you can see this was the actual uh, cases, and network has predicted that for this 10 or 15 days these things are there, these things are going to be like this thing. So this network has not fully or accurately predicted, but predicted. So different, what you can say, then I modified this network, added some more features, and then the network here, not this, another one. Uh, this here you can see another network, but it is missing. It is missing as compared to previous one. It is actually having higher divergence. So these are actually here this network time distributed layers are there. If I am not wrong, yes, I did this time distributed layer and it could not perform well. Earlier was simple what you can say vanilla network. that we are implementing, comparatively that performance is better. Yeah, so you can explain, you can explore this, what you can say, various types till the network is getting trained. Seven epochs are there, so it will take time. So yes, and many times you will see applications of this of, sharing will conclude application of these LSTMs. You will see in natural language prediction, then sequential data translation. Uh, Whenever you will see that like tweets and its analysis, and based on past tweets we want to predict something on natural language prediction, but what you can say time aspect also. So whenever such kind of research or activities are there, these recurrent networks LSTMs are there, then there is concept called as attention. So attention is another mechanism, like we are having this forget gate. This attention mechanism gives more, what you can say, control over what you want to remember from the past and how you want to remember from the past. So these transformers and these LSTMs with alternation networks, many variations are there. Those who are working in this neural networks and sequential data prediction, they can explore this thing. Okay, so we are having some unwanted visitors. Let it be. So thank you all for your time and listening to this presentation. If you have any doubt, you may please post it on comment. I will answer that, or maybe you can meet me personally. Further, if you want any material or this code or this PPT, I will share everything with you. I am just putting my email ID here on the screen, in the comment also. Yes, so if you have any doubt, or you can mail me here on this. So if I have uh, got an address, what are your doubts, or I have given you some takeaway, I will be very happy. So thank you all. Have a good day. Okay, I am ending this in just a minute. Let me take the screenshot. Yes, thanks. I'm ending the session.